Parallel circuits. Parallel circuits have exactly two nodes. A parallel circuit is one that has two or more current paths connected to a common voltage source. So here we have one node, and the two tops of these resistors are connected and the two bottoms. So end to end the resistors are connected. If I wanted to connect these in parallel, I would just draw my line. Let's not add any resistors here. Just draw my line to connect. So I have the resistors are connected here together, and they are connected here together. Now this one, if I wanted to connect these, again, end to end, they're connected. And the current path is when the current comes out of the source and gets to this junction, it divides. It's recombined at point A and travels back to the voltage source. Parallel circuit rule for voltage. Every component has the same voltage across it. The voltage is the source voltage. For example, the source voltage is 5 volts. What will the meter read if it is placed across each of the resistors? Well, since if you look at these points end to end, everything is connected with a wire right back to the source, so they all have 5 volts across. The total resistance of resistors in parallel is the reciprocal of the sum of the reciprocals of the individual resistors. To make a long story short, it's 1 over 1 over. So in this case there's 3 resistors. It would be 1 over R1 plus 1 over R2 plus 1 over R3. 1 over 680 is 0.00147. 1 over 1500 is 0.000666. And 1 over 2200 is 0.000454. So I add all the reciprocals up, and I get 0.00259, and the final step is to take 1 over 0.00259, which gives 386. Tabulating current, resistance, voltage, and power is a useful way to summarize parameters in a parallel circuit. Continuing with the previous example, complete the parameters list. So we found the total resistance was 386, so my total current is going to be 5 volts over the 386, which is 12.9 milliamps, or 13 milliamps. To get individual currents, I would take 5 volts over 680, 5 volts over 1500, and 5 volts over 2200, and that will give me my individual currents, and the individuals add up to 13. All of the voltages have 5. There's no calculation to get that. And power is just a matter, once I know all the quantities, I can just pick a formula. So if I use V times I would take each V and each I, multiply them to get the power. Kirchhoff's current law is generally stated as the sum of the currents entering a node is equal to the sum of the currents leaving the node. Notice in the previous example that the current from the source was equal to the sum of the branch currents. So in series circuits, the voltages add up to the source. In parallel circuits, the currents add up.